In this video, we will learn how to find out the demand function from the given indirect utility function. The question is, consider the indirect utility function as V is equal to M square divided by 4 P1 times P2. M denotes the income of the consumer, P1 and P2 are the prices of good 1 and 2. We have to derive the demand function for good X1 and X2. Okay, so here what will we do? We will use Roy's identity. Okay, so we will use Roy's identity to find out the demand function for good X1 and X2. Okay, it is a shortcut way of finding out the demand for good X1 and X2. Okay, so Roy's identity says that given this indirect utility function, that is the demand for good X1 will be equal to the ratio of the partial derivatives of the given indirect utility function with respect to price and income. That is, the demand for good X1 will be equal to, that is equal to minus times, that is the partial derivative of indirect utility function with respect to price of good one divided by the partial derivative of indirect utility function with respect to income. Okay, so first we need to find out this dv upon dp1. So dv upon dp1 means we partially differentiate this indirect utility function with respect to p1. So how do we take the partials here with respect to dp p1 here? So let me rewrite it here. We have v is equal to m square divided by 4 p1 P2. Can I write it in this fashion? V is equal to, transposing P1 to the numerator, it will become M square P1 raised power minus 1 divided by 4 P2. Okay, for the sake of simplicity. Then dV upon dP1 means I can take the partial here. Okay, so using power function rule, derivative of P1 raised power minus 1 will be equal to, minus 1 will become coefficient first. Okay, so we will get minus 1. So I will only write minus here. Then we have m square p1 and exponent is subtracted by 1. It will become minus 1 which is minus 2 divided by 4 p2. Okay, so it becomes minus m square divided by, if I transpose this p1 raised power minus 2 to the denominator, again I will get p1 square, but exponent will change obviously. It is minus, if it is minus 2 it will become plus 2, then we have p2. Okay, this is the derivative of dv upon dp1. That is, we get minus m square divided by 4 p1 square p2. Similarly, we need to find out another derivative, that is dv upon dm. dv upon dm means we partially differentiate given indirect utility function with respect to m. Derivative of m square is twice m, so it is very simple. Here we get 2m divided by 4 p1 p2. Okay, now using this ratio, x1 is equal to this stuff, so we have minus from the formula. Now dv upon dm, dv upon dp1, we got it as let me write it here, minus m square divided by 4 p1 square p2. Okay, divided by dv upon dm, and from this dv upon dm we calculated it as 2m divided by 4 p1 p2. Okay, so let us try to solve this. It will become minus into minus is plus, so we will get m square divided by 4 p1 square p2. If I transpose this, it will get multiplied but reciprocated. It will become 4 p1 p2 divided by twice them. Okay, here we can do some cancellation. 1m will get cancelled. Here 4 and 4 gets cancelled. P2 gets cancelled. And here 1 p1 will get cancelled with this p1, so we will be left with, here we are left with m, and here we are left with 2, and here we are left with 1 P1, that is P1. That is x1 is equal to m divided by twice P1. So we got the demand function for good x1. Symmetrically, to find out the demand function for good x2, what will you do? You will find x2 is equal to the ratio of the partial derivative of the indirect utility function with respect to price and income, that is dv divided by dp2 divided by dv divided by dm, but we write here minus sign. Okay, to find out the demand function for good x2, we take the partial derivative of the indirect utility function with respect to price of good 2, and we divide it with the partial derivative of the indirect utility function with respect to income. Okay, so yeah, this is left for you to calculate the demand function for good x2. I hope I make myself clear in this video. Thank you.